Today we're going to have a short and sweet, hopefully, lesson about changing repeating decimals into fractions. This is crazy. This is one of those situations where even if you are allowed to use a calculator, what do you do? Because the calculator is showing you a repeating decimal. How do we change it back to a fraction? Here's how you can do it. We're going to start by using algebra, and then we're going to use those kind of puzzle solving skills to establish an algorithm. An algorithm is just a set way of solving a certain type of problem. Once we figure that out, I guess you can think of that as like a shortcut, but you'll be able to prove the shortcut with this method here. So first of all, instead of just having my 4 repeating, which of course with the vinculum there, the vinculum tells you, hey, that number goes on forever, and that's a way of expressing that without taking forever to write it down. So as long as we know what that stands for, we can therefore, why don't we set this repeating 4 equal to x. Okay, now we have an equation. We can manipulate an equation to get it to do what we want. What I'm going to do is I'm going to multiply both sides by 10. Why? Because this single digit that repeats is taking up the 10th spot, right? That's the place value of tenths. So to get rid of the 10th, I'm going to multiply by 10. Here's what I mean. 10 times x is 10x. 10 times a repeating vinculum is 4, now with the repeating vinculum. It essentially, the vinculum doesn't repeat, sorry. It moves the decimal over one spot, is what multiplying by 10 does. Now, since we know that x is equal to this piece of the equation, and I want to get rid of that so I can understand what's going on here, I'm going to take away x from both sides. And you might say, wait, that's not an x. That's not x, Mr. Whitcher. It is, because since x and the repeating 4 are equal, if I take those two things away from each side, I'm effectively taking away x from both sides, keeping the equation balanced. 10x take away x is 9x. 4 with the repeating 4 take away the repeating 4 equals 4. That looks much cleaner, and look, the vinculum is gone. Poof. Gone. Then we simply divide both sides by the coefficient of x. That's 9, the number next to the x. And what I'm left with is the fraction. The fraction that's the same as 4 with the vinculum over it. Okay? Nice. Easy money. Let's have you practice one. Do this. Practice that. Pause the video. Do that very quickly. Come back. I'll show it to you. Bye. Welcome back. Let's change up the color here so you don't fall asleep faster than you already are. All right, 6/9. Whoa, what just happened? What just happened? Oh, okay. What was that? There, practice that one. We do these in one take, so we don't care. We're going to keep plowing. All right, hopefully you paused it and worked it out. You're up on that system now. Let's take this repeating 7. First of all, just like in our example, I'm going to set that equal to x. I'm going to multiply both sides by 10 in this case. Why? Because that's the 10th place. That's important to remember, and you'll see when we get some more complicated problems why that's important. Multiply both sides by 10 gives me that, right? Because the decimal got moved over one place value. Now I'm going to subtract x from both sides. Remember, since x is equal to this repeating 7, when I say take away x from both sides, I can take away the repeating 7 from one side and the x from the other. What I'm left with is 9x, 10 take away 1 on one side, and 7, repeating 7, take away the repeating 7, gives us a nice clean equation. Divide both sides by the coefficient of x to get x isolated. And there is that answer. Okay. Well, here's a rule we can come up with. Did you notice something common about these two problems? Once you notice something in common, that's time to come up with an algorithm. Sometimes you'll be taught algorithms in class. Other times, I think it's more fun to kind of figure them out for yourself by observing patterns. The pattern I see here is, in both of these problems, we had a repeating decimal with a place value of tenths, right? A single decimal place. And in both cases, our denominator ended up being the place value, tenths, minus 1, right? So here's our algorithm for single digit repeating. There'll be another video where we're going to talk about double digit repeating, okay? But for this one, single digit repeating, here's the algorithm, which we just discovered up here. We take the fraction is going to be the repeating number goes on top, and on the bottom is the place value minus 1. For example, we can trust that if I had this decimal, if I use the algorithm, all I have to do is take the number that repeats, the 5, put it on top of the place value, tenths, and take away 1. That's what my algorithm says. And we can see that that's going to be 5/9. All right. So we have an algorithm, but we discovered it by using algebra and our problem-solving skills, but then observing what's going on. All right, that's going to do it for single-digit repeating decimals. Why don't you go to, if you loved this, go to the next video, which is going to be double-digit repeating decimals. Woo! Thanks for watching.